Hi friends, welcome to GMK Tutorials. In this video, we will continue our discussion on common source amplifier without bypass capacitor in the analog electronics series point of view. I think all of you having this basically, right? So common source amplifier without bypass. Just only variation is nothing but we are not using any bypass capacitor here. That means if you are eliminating this capacitance, suppose if you are eliminating this capacitance, the remaining part is also same. This is the generally bypass capacitor. Okay, if you are eliminating this one, this is the analysis for this case. That is the only variation. But at that time, what is how the problem is changes? That means how the equations are going to be changes. So this is a small signal model for representation, like RG resistance, supply voltage VDD is ground connected, and RD and RL. RL dash is nothing but obviously it's a two values. RL dash is equal to, it is the parallel connection of drain resistance or the parallel with RL. This is the meaning of this. RL dash is equal to, this is the equivalent value. At the same time, the small signal model for the circuit is nothing but obviously small signal circuit means that just you have to represent the small signal model for this case. So small signal model means that obviously you have some supply voltage Vs as usual. At the same time, we are connected with RJ resistance like this, but it's a open circuit terminal at gate terminal. So this is generally called a VGS. Okay. So these two are connected like this. So this is nothing but a voltage dependent source here. So this is nothing but some RDS value. Okay. At the last side, you will have some connection that is nothing but output resistance RL dash. So that is the pattern, right? But here there is a small one more variation that is nothing but just I will add a moment for this one. This is a little bit take some for this case. So at this same time, this is a this up to this one it is a very clear guys, right? So this is a source terminal, source drain terminal, it is a gate terminal. This current IG is equal to 0. So that's why it is act as a open terminal. Okay. Now, so here the gate terminal we have a some. So previously it is a bypass capacitor that can be short circuit. Here we don't have any bypass capacitor. So obviously there is some resistance is obviously present. Therefore, that resistance value can be represented as usually. That is can be RS. Okay. So this is a small signal model for this case. This is a small variation here. Okay. So this is a small variation. So this is a small signal model of a common source amplifier without using bypass capacitor. So this I will call this a VS, source voltage VS. This is generally called a RG, okay, RS. So this is nothing but RDS. Okay. So obviously this is nothing but minus GM into VGS. GM into VGS. So this is a small signal model. So in this case, how the problems are going to be changes. So the first one is nothing but current gain. First one is nothing but current gain. So current gain is nothing but obviously can be represented as AI, that is nothing but output current by input current. Output current is nothing but obviously RL dash. That means that is obviously load current divided by input current IG. Therefore IL divided by 0, that becomes also infinity. Why? Because the gate current is equal to 0 in the circuit diagram. Gate current is equal to 0. Therefore current gain is equal to infinity. So second one is nothing but input resistance. Second one is nothing but input resistance. How the input resistance are going to be changes. Input resistance is also equal to RG. Input resistance is equal to RE is equal to infinity. Therefore, that is equal to RI dash is equal to RG. Why? Because it is infinity means that input resistance is nothing but input side. That is nothing but input voltage divided by input current. So Vs divided by Ig. Therefore, that is equal to Ri. Therefore, that is equal to 0. Therefore, Ri dash is equal to, indirectly Ri dash is equal to, that is a parallel of Rg is connected with input resistance Ri. So there is also one more definition for this one. So this is also one more important problem. Okay, important formula. So third one is nothing but voltage gain. So third one is nothing but voltage gain. How we are going to calculate this voltage gain? So voltage gain is nothing but just you have to find the output voltage V0. So output voltage, assume that current through RDS is negligible compared to the RL dash. Okay, suppose if you are connected, current to the RDS is very negligible compared to the RL dash. At that time, output is equal to minus GM into VGS into RL dash. That means just I will consider this current is equal very negligible current. Suppose just here I will assume that low current. Assume that low current flow through RDS. So therefore that's why I will neglect this current. Therefore this is a formula for voltage gain now. Now KVL in the input side we will get. What is the KVL formula at the input side? So this is the one equation. Let it be taken. From the at the same time KVL at input side. What is the input current? So that is nothing but minus VI current, input current plus VGS plus GM VGS into RS. So VGS plus GM VGS into RS is equal to 0. So if you are applying a input KVL at input side, KVL, so this is nothing but KVL at input side, you will get VI minus VI plus VGS, VI minus VI plus VGS minus GM into VGS into RS. So VGM. So here important guys, just see this is very clear actually. So no need to confuse here. So that is nothing but input current is nothing but minus VI VGS GM VGS into RI. That is nothing but the current flowing through the source resistance. So that's why this is also included. So this is nothing but the VGS input voltage. So that is the formula for this one. So from this formula, if you are taking a VI and VGS as a common value, what is the value? Therefore, VI is equal to input current VI is equal to, if you are taking VGS as a common value, 1 plus you will get GM into RS. So now you have to find out the voltage gain. So for that purpose, let it be considered, it can be treated as a equation number, just we will call this equation number 2. Therefore divide the equation number 1 with so 1 divided by 2. Equation number 1 is divided with 2. So what is the first equation? Input equation V0 is equal to minus GM into VGS into RL dash. This is the first one, divided by input voltage VI is equal to, so what is the formula here? VGS into 1 plus GM into VGS. This is the formula, GM into VGS. GM is already taken as a common value, right? So let it be strike out for this one. GM into VGS already is common, therefore the remaining term is nothing but RS, source resistance. So this is the only variation. So therefore from this VGS and VGS gets cancelled. Therefore current gain it is nothing but V0 by VA. Therefore voltage gain VAV is equal to remaining term minus GM into RL dash divided by 1 plus GM into RS. So this is a very important formula. So that's why from this formula only, in the most of the current meter circuits also we can write the formula for this case. So voltage gain at V01 and V02 can be represented in case of the differential amplifier also minus GM. Why we are representing minus GM is nothing but it is opposite direction. The opposite direction to the RL dash. Therefore, minus GM into RL dash divided by 1 plus GM into RS dash. So that is a one important formula for in this case also. Okay. So at the same time, suppose if you want to find out the output resistance, so output resistance. So fourth one is nothing but output resistance. So how to calculate the output resistance? So for that purpose, I will call the output resistance can be treated as a R0. So for that purpose, I have to use the Thevenin's point of view. Just I will short circuit the voltage source. Just I will use a RJ resistance only, and this part is generally called a VGS part. Okay, so this is nothing but obviously current voltage source, some resistance RDS. So here load resistance can be treated as a open circuit. Okay, so this is nothing but a RDS. So I will call this is a X, Vx. Okay, so this is nothing but a source resistance still connected like this only. So here the bypass capacitor is present, therefore just I will represent like this only. So this is the representation. Okay, so this is a Vx, overall Vx. So this is a VGS. So in this circuit, obviously you know this one, GM into VGS. This is nothing but RDS. So from this circuit, if you are applying a, so now you have to find out the output resistance. Output resistance R0 is equal to output voltage divided by corresponding current. So that means outside the current, right? Therefore, output current into output resistance. Output voltage is nothing but Vx. Output current is nothing but Ix. So for that purpose, you have to calculate the Vs is a short circuit, RL is a disconnected. Apply the Vx at the output loop. Okay. At the same time, first of all, you have to apply the KVL in the loop 1. At the input side, you will get a input side VGS plus Ix into Ix into Rs is equal to 0 for first side. That means KVL in the first loop. First of all, you have to apply the KVL in the, this is nothing but a RG, right? So apply the KVL in the loop 1. So suppose if you are applying the KVL in this one, VGS into the current passing through the RG, that is nothing but I will call this current is equal to, for time being, Ix. So here no current is passing, but in this current VGS minus Ix into Rs into corresponding RG value is equal to 0 obviously. So we don't have, it is a short circuit, right? So therefore just only the corresponding two currents only present in the analysis point of view. Okay, therefore VGS plus Ix into Rs is equal to 0. So from this, what is the value of VGS? VGS is equal to minus Ix into Rs. Like consider equation number 1. At the same time, write the KVL at input loop. At the same time, now you have to write the KVL at output loop. So write the KVL at output side loop. So what is the KVL at output side? Output side loop is nothing but output voltage. That is nothing but I will take minus direction as per your convenience. Minus Vx plus I will call that current is equal to Ix current. Therefore, the current passing through this one is equal to Ix into opposite current Ix minus opposite of that current is equal to Gm into VGS, Gm into VGS, Gm into Gm minus VGS. That means the remaining current is nothing but Ix current is equal to difference of those two current, Ix minus Gm VGS, Ix minus Gm VGS, that represents the current passing through the corresponding RDS. Therefore, that is nothing but difference of RDS plus IX into RS is equal to 0. IX into RS is equal to 0. So from this, you need to calculate the Vx by Ax. So therefore, you will take out the corresponding common terms. Therefore, Vx is equal to just if you are taking to the right side, Ix is also present here also. Ix is also there. Therefore, the complete term is equal to Ix RDS minus Gm into Vgs into RDS plus Ix into RS, right? Now you have, from this equation, you have to take only so Vgs is equal to minus Ix into RS. So therefore, Vgs is equal minus Ix, and so therefore you have to replace this Vgs value with minus Ix into RS. Therefore, it becomes as a positive Ix into RS into RDS. So from that, substitute that value, you will get the equation as Vx is equal to minus Ix into RDS plus, just no need to represent, plus Ix into RDS plus the positive sign, it becomes as a Gm. Vgs is replaced with minus Ix. Actually, the second term is nothing but this is the value, right? Gm into, so here just you will replace Vgs value with, for this one, minus Ix into Rx. Therefore, it becomes as a positive. So Gm into Ix into Rx into RDS value. So Gm is into Ix into RDS and RS plus Ix into RS value. So from this, you need to calculate the Vx by Ax, that is nothing but output resistance. Therefore, that is equal to what is the value? That is equal to output resistance R0, that is equal to RDS. If you are taking Ix as a common value, so the only RDS plus Gm into VDS into RS plus RS. So this is the remaining term you will get in this equation. So it is also equal to, represented as RS is also common value. Therefore, RDS, drain to source voltage, plus if you are taking RS value as a common value, then you can represent 1 plus Gm into VDS. So mu is called as a amplification factor of a FET. So Gm into, so just we will reach to the last document. Just I will wind up this session here also. So this is nothing but output resistance R0. Therefore, output resistance R0. So from that, R0 is equal to RDS into RS into 1 plus Gm into RD. So it is very important, guys. Already discussed this problem related to in case of the multi-stage amplifier also. This is the formula we are taking from this equation. Okay. Suppose if you go for the MOSFET point of view, this is the formulas for calculation of output resistance, input resistance, voltage gain and current gain. Therefore, it is very important to note that one. So therefore, I will call another name, R0 dash is equal to, so here R0 dash is equal to, R0 is parallel with RD. R0 is parallel with RD, you will get an output resistance. It is very, very important. Very, very important formula. R0 dash is equal to R0 parallel with RD. Okay. At the same time, I will call a one name actually. For this one, I will call as a mu. So this is nothing but mu is equal to Gm into RDS. Cm into we can call RDS, right? VGS substituting if your VGS is equal Ix and R, therefore Ix into RDS actually, okay, RDS only, not a RDS, so therefore it is nothing but RDS, that is equal to RDS. If you are replacing this, it becomes as a RDS only, not a VDS. So it is nothing but RDS. Why? Because it is RDS. Actually, from the given formula, Ix, just you are replacing with the VGS with Ix into RS only. So therefore, it becomes as a Ix into RS only. It changes only Ix into. So from this equation, it becomes as a GM. So VGS is equal minus into minus plus. Therefore, Ix into RDS as usual, it becomes as a RS. That is the only additional part. So that is the only additional. So it can be treated as a mu. Okay, RDS into mu. So therefore, it is also can be represented 1 plus mu format also. Therefore, R naught dash is equal to R naught is equal. Just I don't want to represent R naught dash, already represented. R naught is equal to, that is equal to RDS into RDS plus RS into 1 plus mu. So this is a formula for calculation of a output resistance R naught, where mu is nothing but a amplification factor. So mu is nothing but amplification factor. So thank you guys. Thank you for watching GMK tutorial for latest videos. So please subscribe channel, share channel, like channel. So thank you guys. Thank you for support.